and welcome to my midterm video. So I've been assigned to do question number 23. And that's on this compound shown right here. And this is cis-1-bromo-4 fluorocyclohexane. And the reason why it's cis is because, as you can see here, these solid wedges mean that these molecules are facing the bonds that are upwards. So it doesn't mean that they're both axial, but it means that they're facing upwards. And so that's how we know that this is cis. So I have my two chair conformations here. I have one right here with my bromine on this carbon, carbon 1, and then my fluorine on carbon 4. And then on this one, chair 2, I have my bromine on carbon 1 on this part, and then I have my fluorine on carbon 4 over here. So the difference between these two is that when I ring flip this one, my axial bromine becomes equatorial, and my equatorial fluorine becomes axial. And so I can also show that with my molecular model right here. So this is my first chair. I have my fluorine right here and my bromine over here. And so this is analogous to chair 1 as shown there, if you can see that. And so I'm going to ring flip this. So I take one hand here, one goes up, one goes down. I'm going to ring flip this. So now all of my axial bonds have become equatorial, and all of my equatorial bonds have become axial. So at this point, I have to determine which one is more stable. And the one that's more stable is in fact this conformation. And the reason for that is because this bromine is larger than this fluorine. And when the larger group is in the equatorial position, so in this case the bromine, that is the more stable conformation of the chair. And the reason for that is because the electron cloud here, there'll be a lot less crowding with the ones surrounding this molecule too. So there'll be less steric hindrance. So I'll show that on my paper here in just a second. So chair conformation number 2, that is the most stable of the two chair conformations. And again, the reason for that is because the larger group is in the equatorial position and the smaller group is in the axial position. So we know that bromine is larger because if you look at the periodic table, bromine is lower on the periodic table than fluorine, which means that bromine has a bigger atomic radius. And so that means that if bromine is in the equatorial position, there'll be less crowding with the atomic radii of the surrounding atoms. So, and right here, this illustrates that this is the much more heavily favored conformation. So hence the larger arrow pointing to this conformation and the smaller one pointing there. So at any given moment in let's say like in a mole of this, there will be a lot more of this conformation than of this conformation.